Hello everyone, welcome to the past paper discussion. We are in fifth question of this particular series. Yeah, so we can just get into this. It is a calculus based question, particularly integral calculus is involved. Right, Adesh is designing a glass. The glass has an inner surface and an outer surface. Part of the cross section of his design is shown that we can see in this graph. And it is, we can easily see that this glass is enclosed by two curves, right? So f of x is given and g of x is given. So this inner surface is f of x because it have the intercept 1, right? So that in that we can be here very clear. And g of x is x minus 1 the whole power 4. Of course, it have the origin, right? So that's why we define inner as f of x and outer as g of x. Now, they are defined in this interval 0 to p. G of x is defined as x minus 1 the whole power 4 for 1 to p. What is p? Actually, from 1 to p, we can see over here. Then from 0 to p. So this point of intersection of these two graphs is p. So finding p, it's very simple. Using GDC, we can just graph them and find the intersection point. Right? And moving to the GDC now. So that's the basic concept. Here, identifying the function is more important. So which is inner surface and outer surface. This will be important to carry out the next level problems in this. Here we go. Okay, so I can just define this whenever you're solving. So define the function f of x is half x cubed plus 1. So 1 by 2 x cubed plus 1. Okay, we need to define this. So in order to define, you just give a semicolon and this. That's it. It is defined. So whenever we are dealing with, no need to type the entire. You can just go with f of x and g of x, the names. And this is g of x is x minus 1 the whole power 4. So define this. You have to give semicolon and equal. And it is x minus 1 the whole power 4. Right. Done. Now let's see. We are looking for the graph's intersection point. So you just go for graph, and first graph is f of x. You just give the name f of x. It's done. So I need to give one more graph entry. So go for menu, graph entry edit. We have to give a function, and it is g of x. Okay, so these two meet, and we can see our let me just zoom to the first quadrant. That is what we are working on. We can see that glass model over here, and I can see the point of intersection is over somewhere around here, right? So I need to find the intersection point. So go for menu, analyze graph, intersection of the two graphs. So from here to here. That's it. I got the intersection point. That is my P. Right? So P value is found. Let's just take this and interpret the result. Very simple. First part. And here in the solution page, the value of P is 2.91802, comma 13.33. So what should I go for? 2.91, the x values, right? So P is 2.91 to 3 significant figures. That's simple. Now, the next part is the glass design is finished by rotating the shaded region in the diagram through 360 degree about y-axis. Okay, so if you rotate this 360 degree about y-axis, it will become a 3D shape, right? So now for this, find the volume of the liquid that can be contained inside the finished glass. So like the capacity, correct? So how much it can hold it inside. And one more question is there. Find the volume of the region between the two surfaces of the finished glass, right? So basically they mean the two different things is here, if you have a container like this, this is a kind of volume, right? So if you have a glass container like this is all made up of glass. This is volume. And another volume also will refer how much it can hold. So the green part is how much it can hold inside, and outside, like it is related with outer surface area when I calculate the volume of the glass used to make that container, right? So that's what they mean. Okay, and coming to this, the clue is 360-degree about y-axis. So y, it is available in the formula booklet, the formulas, but we need to choose which for which, right? So I will pick, since it is about x-axis, y-axis given. So for the inside finished glass, okay, what is the inside surface? I will go with, if it is y-axis, x squared dy, right? If I am rotating, rather, if the revolution is about y-axis, you should have the slices along y. So dy, it should be there, correct? So volume, first you find the formula A to B. Let me take pi outside, x squared dy. Now what is x squared? I know f of x and g of x, but which function have to be used? Or, right? So since they are asking for inside, how much the glass can hold, so you take the inner surface function. F of x is nothing but y. F of x is given, it can be interpreted as y, which is half x cubed plus 1, correct? Now I want x square, so you make x as a subject or x square as a subject. X square will be better, so we need to convert that. That's the only part. And also we need to find the bounds. And f of x ranges from 0 to, if I'm not wrong, no, it's 1 to, right? So 1 to that p value also we need, right? Right, and this is for x, but for y, because my integration is around y, correct? Like we are slicing it along the y-axis. So your bounds also should be related with y. That is one more important thing we need to notice here. And we can, actually for x, it's 1 to 2.91. Right. Okay, so bounds, we can just get it from the graphical part. Yeah. So we got this, but why we need to solve for it? Let's get it from the graph as of now. So now let's simplify this. Let me take the 1 over there. You will get y minus 1 is equal to half x cubed, and take 2 in the 1 by 2. If you shift, it's 2 times y minus 1 equal to x cubed. I need x square. So let me divide by 3, like take cube root on every side, right? So 2 power 1 by 3, y minus 1 whole power 1 by 3 equal to x. I want x square, so square it on both the sides. So this is your x square. And just we can complete it. And actually the bounds, coming back to the bounds, okay, here we didn't have the full image. Let's go back and check what are the bounds for this integration. Wait a moment, let me zoom out. Okay, now it's quite clear to us, correct? We are working on the blue graph, and it's 13 point, y bound is what we need, not x. So 13.3315, and here it is actually 0, 1. And 1 to 13.335 is 15 is the bound, right? So that is another important one. Now moving to the solution page. So this volume is nothing but pi integral 1 to 13 point. We are using, let's use 3315 itself. Final answer we can make into 3 significant figures, but as of now, you just take as much digit as possible, right? And this function here, there is a pure constant, right? I should substitute x square is this. So that 2 power 2 by 3, and then it is y minus 1 whole power 2 by 3 dy. That's it. We need to solve for this integration. We can just switch to the graph, that is graphic calculator again and complete it. Here we go. Take a new page. Okay. I need to solve for an integral. So let's start. Go for the integration with limits. So I'm solving for 1 to 13.3315. And here it's based on y. Y minus 1, the whole power. I missed something, but I will include by this. Power 2 over 3, a fraction. 2 over 3 with respect to dy. And where are the constants? Like outside the function, we can just put pi. So go for the pi value times 2 power 2 over 3 we have. It's 2 power 2 by 3. Okay. All of them have been perfectly given. Just we need to evaluate to get the volume. Right. So let's hit the enter. 196.946. Right. So that's simple. Here we go. So I got the volume of the liquid that can be put inside is this. So let it be volume. Let me name it as I. And it is 196.946. Right? That's simple. Cubic units have to be mentioned over here. That's it. Now, next part is the same. The glass design is finished by rotating the shaded region in the diagram through 360 degree about the same y-axis. But there is a different question C. Find the volume of the region between the two surfaces of the finished glass. Right, and we can just go ahead. Right, similar formulae, the same which we have used over here. Not the same, but in the formula booklet, we have to find it which is suitable. So C part. Actually, this is C. Right, so since it is same y-axis, so of course this formula, the limits will get changed since we need the inner surface, right? So that is in between the two, like a sandwich. This function inner surface, outer surface, and between them, how much of the glass is over there. That volume of the region we need. So inner surface we already found. For outer surface you found, and then just subtract it. That will give the volume of the region required. So volume of outer surface, let's find. So it is pi into integral a to b y square. Wait, we used x squared, right? It's about y-axis, so this is the formula to be used. X square dy. Okay, again, outer surface, the function is quite different. So we need to take that. G of x is my y now. And it is x minus 1 the whole power 4. It's quite easy. Y power 1 by 4 equal x minus 1. And your x is y power 1 by 4 plus 1. I need x square, right? So y power 1 by 4 plus 1 the whole square. So we defined x square here and just substitute it. Okay, coming to the bounds. The bounds will be same from the previous graph because we have both the graphs over there. So we can just refer. The bound is running from 0 to the same point. The P is same. Correct? Let me show you. So here it goes from 1 to the x is actually running from. For g of x we are solving, it's 2.91 something. Now, but we are solving for y, again the same thing. The respective y value, when p is 2.91, the respective y will be this, which is 13.3. We can just take the full value, 13.3315. And this is the upper bound. Lower bound will be, there we took 1, right? When x is 1, there it is 1. Actually, this is the x bounds, 1 and 2.91. So the respective y bounds will be, when 2.91, this is, when x is 1, what happened to y? So you can just even substitute there. 1 minus 1 is 0, 0 power 4. So 0, right? And then that's it. This completes the volume of outer surface. Pi integral 0 to 13.3315. And the x square is converted into the form of y. Y power 1/4 plus 1 the whole square dy. Again, with the help of GDC, we can solve this one. Right? Hope it might be clear. Moving here. So similar one. Instead of 1, I should put 0. Then 2 power 2 by 3 is not there. Okay, anyways, let's use the same thing. So pi, then integral with limits. And it's 0 to 13.3315. Then 1 plus y power 1 by 4 plus 1 whole square. Right? So insert the function carefully. Y power 1 by 4 plus 1 the whole square and then dy. That's it, and click the enter. We got 271.877 centimeter cubes. That's it. This is the outer surface area. To find the volume of the region in between, so VO equal to 271.877 centimeter cube. So required volume in C case, we are solving for C. Required volume is outer surface minus inner surface. Outer surface will have more dimension, right? 877 minus volume of inner surface, we found it around 196.946. Normal subtraction. And then you round off to 3 significant figures. You will get it 75. Around. Okay, so 272 minus 197 will be approximately 75 centimeter cube. Right? And this completes the solution for this problem. Thank you so much for listening. Let's meet in the next video with an interesting math stuff. Until then, keep learning. Let's meet in the next video.